let's talk about AC/DC. And nope, not the band. We're diving into the epic electrical battle that literally powers everything in your life. Seriously, from your lights to your laptop, it all comes down to this one incredible story of a rivalry that turned into the most important partnership in the modern world. You've seen these letters everywhere, right? Well, they stand for two totally different and, for a long time, competing types of electricity. We're talking alternating current and direct current. And together they run everything, from the massive power grid that spans the country to the tiny little circuits inside the phone you might be holding right now.
Okay, so to get what's going on, you only need to understand one key difference. Think of direct current, or DC, like water flowing steadily through a hose. It's a one-way street. Simple. But alternating current, AC, is totally different. It's more like a piston, pushing water back and forth, constantly reversing direction. And that single difference, that one little detail, is what kicked off one of the biggest engineering battles in history.
So this brings us to the first huge problem our electrical pioneers ran into, the long-distance power problem. I mean, it's great if you can make electricity, but how in the world do you get it from the power plant to people's homes and factories miles and miles away? Well, in the late 1800s, this problem literally started a war, the War of the Currents. In one corner, you had the superstar inventor Thomas Edison, pushing his DC system. And in the other corner, you had the brilliant Nikola Tesla, backed by the industrial powerhouse George Westinghouse. And they were all in on AC. It was a massive showdown to decide what would power the future. Edison's whole game plan was about small, local power. He pictured a DC power plant in every neighborhood, kind of like a whole bunch of microgrids. But his system had one huge critical flaw. It had a very, very short leash. And here's that flaw summed up in one number: 1 mile. That was it. That was the farthest you could send Edison's DC power before you lost so much energy in the wires that it just wasn't worth it. So trying to power the entire country, especially rural areas, with DC, it was pretty much impossible. So DC had this massive distance problem. How did they solve it? Well, the answer was alternating current, which came with an incredibly clever piece of technology, a secret weapon that DC just couldn't use. And this was it, the transformer. This brilliantly simple device is the key that unlocked our entire modern power grid. See, because AC is always changing direction, it creates a changing magnetic field, and that allows a transformer to easily crank the voltage way up or bring it way down. This was AC's killer feature. So here's how that whole thing works. At the power plant, a step-up transformer cranks the voltage up to hundreds of thousands of volts. This lets the electricity travel for hundreds of miles with almost no energy loss. Then, when it gets to your neighborhood, another step-down transformer drops the voltage to a safe level for you to use. That flexibility is exactly why AC won the war. Okay, so AC wins the war, builds the grid, case closed, right? Well, not so fast, because winning that war created a brand new problem, especially once we entered the digital age. And believe it or not, DC was about to make a major comeback. And this raises a super important question. If the power coming out of your wall is AC, why does every single one of your gadgets, your phone, your laptop, everything, run on DC? They can't use AC at all. So how does that even work? The answer to that question comes from a whole new wave of engineering magic. This time, it wasn't about making power, it was about changing it, right where we need it most. Just think about it for a second. Your phone, your TV, your electric car, every single thing that runs on a battery. It all needs that smooth, steady, one-way flow of direct current to work. So the unsung hero of our modern world is this little thing, the rectifier. It's a tiny electronic component hiding inside every charger you own, and its whole job is to take that chaotic back-and-forth AC and flip it into a nice, clean, orderly line of DC. So, every single time you plug in your phone, this little dance happens inside that power brick. It takes the high-voltage AC from the wall, uses its own tiny transformer to lower the voltage, and then the rectifier converts it to the smooth DC your battery needs to charge up. And this brings us right up to today, where AC and DC have stopped fighting. Now, they're sophisticated partners. And there is no better place to see this incredible teamwork in action than in the world of electric vehicles. So check this out. When you charge an EV, you're really choosing between two different ways that AC and DC work together. AC charging at home is like using a garden hose. It's slower because the car's own little onboard charger has to do all the work of converting AC to DC. But DC fast charging, that's like calling in a fire hydrant. The charging station is a giant rectifier that does the conversion outside the car and then pumps pure DC power straight into the battery. It's way, way faster. So, this amazing partnership leaves us with one last mind-bending idea to think about. We know AC built the grid, and DC powers all our cool devices. But what happens when our devices actually become part of the grid? With stuff like vehicle-to-grid tech, we could soon see millions of EVs sending their DC power back to the AC grid to help out during peak hours. Your car is no longer just using the grid, it's supporting it. The old rivals aren't just partners anymore, they're merging to create a smarter, stronger energy future for everyone.